Right then, welcome everyone to this second lecture on technology. Welcome everyone here and welcome everyone on the internet and welcome everyone who's listening to this afterwards. And the topic for today will be primarily Angular, but we still have a few words on JavaScript left since last lecture, so we'll try to run through that mainly as some sort of information on what's happening. But what you're most interested in knowing is if the groups are ready, and they are almost ready. I'm just awaiting the final words from another teacher, and as soon as I get that, and I hope that I will get that perhaps during our lecture over here, and then I will just post it on Moodle, and you'll see what groups you will belong to. And when you do, I've put you with name and email, and when you do, I would like the first person in each group to get in contact with all the others in that group and begin talking. That person doesn't need to be the project manager or scrum master afterwards. That's just to get started, I'd say. So look out on Moodle. There will be more information. I'm just seeing. Yeah, I'm good here. Okay, so Angular, but first JavaScript, because JavaScript is what's needed in order to make something like Angular. Because JavaScript is a programming language that is used on the client side, so it's executed in the web browser, and that gives the client side a behavior, a possibility to actually do something and not just rely on information being processed on the server side. And it was introduced in Netscape 2 in '95, and they needed something to make it possible to program on the client side, and they wanted it fairly quickly. So the guy responsible for this made the JavaScript in about 10 days, and that shows. And that's one of the reasons we have so many alternatives, as we'll see later on. It became a standard called ECMAScript later on, which is the standardization organization for keeping track of this. And the latest version is ECMAScript, or if you like JavaScript, 2018 from June last year, so we're up for a new version soon. And there are a number of JavaScript engines available. For example, V8, which is perhaps the most known, and then JavaScript Core, which is part of WebKit on the Apple side of things. And JavaScript is primarily used as the tool for, or the programming language for client-side web programming, but it is a language in its own right, so therefore it's quite possible to create other things, like for example the GNOME desktop on Linux using JavaScript. Okay. I just need to check this. So an important friend when it comes to JavaScript on the web is the DOM tree, the document object model, which makes it possible for, I need to be in picture, okay, which makes it possible for Java to get to the different parts of a web page. So internally there is a tree being created with the different nodes, and through this document object model, JavaScript can go through and get to all the different tags, if you like, on the web page, and also the information inside of the tags. So the attributes, but also if we have, for example, a B tag, which makes something bold, you can get to that bold text as well. Practically, we should put all our JavaScript into a separate file, and call that something.js. And just as we did with CSS, we should just read that in the head and add it to our HTML code. We'll be cheating a little bit because we are going to put it inside the head with the script tag, as you can see over here. And previously, we usually commented out the JavaScript part for browsers that didn't run JavaScript, but today everything is running JavaScript, so you don't need to. But we will put it in the script tag inside of the head in our applications just to run it. So this is a complete program where we create a function called message, which just pops up an alert saying hello from JavaScript, and in the body tag we call it via the event onLoad, and we'll go through all the different pieces later on, but just to get a feel for the language itself, and we'll see exactly what we can do. It just pops up depending on what kind of browser, what version of the browser and so on. It will look differently, but this is standard Firefox from a few years ago. JavaScript, as I said, is a language, a programming language, and it has most of the features that you would expect from a modern programming language, although not perhaps in the way that you would think. But it does have statements and expressions, so you can calculate, and you can also create statements like just document write, printing something, and we end with a semicolon, but it's not strictly needed. It's weakly typed, meaning that we don't give any data types to the variables that we create. So if we want a variable called name, we just say so. And if we want to give it a value, just give it a value. And if we want to, we have a var height down there, because we don't need data types, we just declare them with var, if we like, for variable. And if we have height down there, and we assign it 10, and we later on want to assign it the string rank or hoswampa, or whatever we'd like, well, that's actually possible. And that means that to compare two variables, we apart from the normal equal sign also have the equal sign with 3 equals after each other, like this, in order to check both the content and the data type. Selection, iteration, and so on. Well, the idea with JavaScript was to make it something that you would feel familiar with when you see it and when you work with it. So if statements and for loops and so on, they work basically the way we are known for them to work. So for example, if height is larger than 9, then write out that is tall. For a for or a while loop, we do something like this. The only thing that's a bit strange is that we use var instead of using a data type, but that's just because the language doesn't really care for data types. There's a for-in version also of this for loop, so they have a few more bells and whistles.
So we don't, when I write the variable, I don't care it is integers or the string, I just write a var and say the value.
Yeah, you don't care exactly what kind of variable it is that you want to loop over. But we will fix this later on. Yeah, and here's the complete code. A function prints something where we declare a number of variables. We print something out with string concatenation. We check for an height, and we print go 3 times. So something like this. But wait, you can do more with JavaScript. Arrays and functions. Arrays first. There are a number of ways of doing arrays. just declaring an object of type array, or we just declare something and add a bunch of values to it like this. And this it's possible to use the normal bracket notation, but there's also a method push that we can use for arrays as well. Something that's been kind of good coming from JavaScript are these associative arrays, where we, instead of having index numbers, we say that that's brand and the value should be Volvo and the type should be V60 cross country, like this. And in this way we don't even have to have the quotation marks over there, and this way we can create something that we will later on see as the JavaScript object notation, a way of packaging objects in a way that's fairly easy to move backwards and forwards. I don't know where the functions went, but they will return. We have events first, and events are just for reacting to things that happen in a web page. So they are more to do with actually with the web itself and the DOM tree and so on. And this makes it possible for us, for example, to call this onload, which we've seen previously. But we can also have onClick for a button, or onFocus, or onSubmit, and so on. So it's possible for us to create a button and have an event called onClick, which we'll call showAlert, which is a function as we see it over here. And it looks like this. And if you think I'm going really fast, that's quite correct, because later on we are going to look at TypeScript instead as an alternative to JavaScript. Functions. Right. So functions work mainly the way that you're used to. We have a keyword called function to say that we want this to be a function. And we give it a name and then a number of parameters. But as we don't care for data types, we don't have a real return type. So we can create a function that returns the sum of two incoming integers, or we don't know what it is, but it returns the plus of those two to whomever called for it, and then it will give it. Yes?
If there are no predefined data types, what if, for example, A is a string and B is an integer? What
Yeah.
would the function do in this case?
Yeah. And the question is, if A is an integer and B is a string, or the other way around, what will happen? Well, whatever happens if you try to in that case, you will probably concatenate a string and a integer, and you get that string back. And this exact thing with no data types, as we have it over here, is one of the greatest problems with JavaScript, because it's terribly difficult to try to find errors because of this. Because anything goes, basically. You can send an integer and a string or whatever to that function. And that's the reason why we are going to look more at TypeScript later on. But during the time when JavaScript appeared, so in the mid-90s, and way into the early 2000s and so on, there was an uprise of languages which didn't impose as much onto the programmer as the previous programming languages had done. So if you look, for example, at C or C++ or Pascal or whatever, the old programming languages, even Java for that matter, they say that you should do it like this. If you look at Java, you have loads of code around. If you want to print hello world, you need to create a class, you need to create a main, you need to call a system out print line and so on. And this JavaScript thing is very much a reaction to that. We want something fast to work fast with. Let's do away with all the stuff that's in the way. I don't want to know what my variables are. I don't care for data types and so on. And it's been that for a long time, but now we are, as far as I can see at least, turning back to getting our data types back again. I like data types. JavaScript is an object-oriented programming language. However, it does it in an interesting way and not as you would expect. And I will just browse through this because we are going to work in a completely different way later on. But one of the things, just as I said previously, don't impose anything on the programmer. So you don't need to program object-oriented in JavaScript. You can if you like, but you don't have to. So it's up to you. For ECMAScript 2016, they overhauled the programming, object-oriented programming, because it's implemented with something called prototypes instead of classes and objects as we are used to. But as I said, we're not going to look very deeply into that. From time to time, it looks exactly the same as any other object-oriented programming language. And that means that we have a number of predefined objects in the library, like array, boolean, date, function, math, number, and so on. So we can declare something like a new date like this, with new date, as we've seen in other languages, and we can call it, if it was called tomorrow date is a new variable, set date for that one, tomorrow date, get date, +1, and so on. So one of the implications of the way that JavaScript internally uses object orientation is that you can do something like this. If you want to create a new object, a new person, which is an object, you can do that like this. Just person, new object. Okay? And if you want to add an attribute or a field called name, you just do that. Person.name equals to Anakin. And if you want a function or a method, as we say, to this person, you just assign it like this. So showName is now a function which pops up an alert like this. And this means that if I, for some reason, create a new attribute called, I might be misspelling name, so I spell it N-A-E-M. Well, then I've introduced a new attribute to this object. So no type safety. However, using the associate arrays, we get JavaScript object notation, which makes it look a bit more like a normal object-oriented example. But later on, as I said, 2016, they created some syntactic sugar over the old way of doing it, so that we can create something that looks like this, like normal object orientation. We create a class, it has a constructor, it's called constructor, but hey, we understand. And we add a number of methods to this, and we can call and create and so on around this. Yay, it works. And with the document object model, as I said, we can get to different parts. We can do it like this. We call for the document. We know that there are a number of forms on it. We take the first one, 0, and we go to the converter element on that page. And we can get information from that or add information. A number of useful properties in a text, get element by ID or tag name and so on. And instead of going through all of this, I'll show you a few examples. Here, what we want to do is to look at this text, and we've marked it up with spans. So cad bane and Duro, over there Duro, are spanned, and we later on just print out whatever is inside of those spans. So it looks like this. This is the text again. So we have a span with the ID name, and we have a span with an ID planet. And down here we introduce some JavaScript where we go to the document and find the element by ID name, put the content or the element itself to this variable, so that when we write the name.innerHTML, we get the information that was available in that element, which was cad bane. And we can do it the other way around as well. So in this case, we have text where we have an ID of name and an ID of ship, and then we have a button with an on-click where we call the method change text. This method will find name and instead set the inner HTML to Tobias and Volvo. And then we get something like this. The original text, Bosk, meaning devours his prey in Dosh, was a Trandacian bounty hunter, blah, 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 and the pilot of the Hound's Tooth. If we press the button, it will change, without necessarily doing anything else, change Bosk to Tobias, meaning devours his prey, which isn't true, because if I remember correctly, Tobias means something like God is great. But I do pilot my Volvo. Yeah. Great. Oh shit. Oh, sorry. I thought we were done. Ajax. So, in conjunction with JavaScript, we also need to at least mention Ajax, which is a add-on, so to say, which makes it possible for, or a library, or really an object that makes it possible for us to create partial updates of a web page. It is going to be used in the background, probably by Angular, but we are not going to directly use it. So this makes it possible to create a web application that behaves more like a standalone desktop application, in that we don't have these constant redraws of the web page or reloading of the web page. Normally in HTML, if you press a button, as we saw last time, it will take all the information back to the server and it will reload the page, possibly with new information. However, sometimes we just want to update a small part of the screen, and we can do that using Ajax. And the idea here is that we have an object called XML HTTP request, which makes it possible for us to make a background call to the web server, or the server, whatever it might be. And it's actually an invention of Microsoft for Outlook, but it has become standard. Yeah, and we create an object. We use these different methods in order to retrieve, send or retrieve information. Here's a simple example. So, who's both a Jedi Master and an ace pilot? If I press the button, the answer will be C13, like this. And you can't see it here, but it does this without flickering the screen. So it will not update the web page, the entire web page, but rather it will only update this part. And the code isn't very much fun. And you should never ever do it manually like this. So the idea is that we down here we create an object, we get the data source, we read and see do we get anything. If we get anything, we put it in our HTML. We put the data that we find on the web server. And where do we put it? Well, we put it in this here, the target div. And you can look more closely if you like, but as I said, we are not directly going to use Ajax, but it's an important technology to know of, as many libraries, like for example Angular, but also Bootstrap and things like that, use it behind the scenes. Blah, 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 blah. More on JavaScript. Basically don't, no. We'll go for something else instead. But I found, as always, W3 School and Mozilla good places. JavaScript info, Java, T-Point, YouTube, Google, or DuckDuckGo, or Yahoo, or is there anything else? Bing, yeah. Yeah, right. But most importantly, use the web search engines for getting the correct Stack Overflow forum post for your question. Right on. Let's begin with Angular, which is the topic of today. And Angular is something much more interesting because now we are going to create our web application. So all the stuff, with the stuff that we've seen so far, HTML, CSS and JavaScript, we can create a web application. But it is tedious, it's a lot of work, and there's a lot of stuff that people have done already. So with Angular, we get a complete framework for creating web applications. It does so by combining the different technologies and also, in our case, creating a really nice environment to work with. What it is a JavaScript framework that creates single-page applications. And that in itself means that we are basically just going to create one web page. But this web page will be modified by, well, the user basically, by going to different places. So we will still be able to go to different, press different links and stuff like that. And in the URL, we will have different, well, we will have different URLs. So if we press a link, it will say something else in the URL, but we will still be on the same exact web page. So we will just modify the web page. All of that modifying stuff is done by Angular, so we don't need to care how it's actually done. But it is done, and it is done by Angular. And that also means that Angular works by the user downloading basically the entire application to client side. So the first download when they get to our page means that they will download everything that has to do with what it looks like, what pages, so to say, are available, what they can do, and so on. They will, of course, not download all the stuff from the database or something like that, but they will download everything else, basically. And that means that it will take a little bit of time, not much, but it will take a little bit of time to download it, but then it works locally on the web, on the client. So it will be a lot faster when the user has it on their own computer.
How does security work with this?
Security, security, as far as I know, works pretty well. But if you mean things like not being able to go to a specific web page without being authorized, for example, yeah, it still needs to do some calls to the server. For example, we will look at authentication. Yeah, yeah, I think I'm getting tired. I'm getting tired. And when it does that, it will prompt the user to log in, and it will go to the server, get a token that it downloads and places on the local machine. So security is I'd say good enough. Of course, we can always mess it up, but it shouldn't be a large problem. And since it's created and maintained by Google, I'd say that if it's good enough for them, it's probably okay, security-wise. But we'll look a little bit later on in the next lecture when we get to Firebase, how to authenticate users. It also more or less ditches JavaScript and goes for TypeScript instead, and we'll talk a little bit about that. As I said, it's from Google, and it was originally created in 2010, but with a significant update in 2016, and it works with basically anything, and it's part today of the Node ecosystem. When it comes to versioning, we have the first version of Angular, or Angular.js as it's called now, which is something completely different from Angular 2 and later on. And we are only interested in Angular 2 and later on. And for the most part, from 2 and on, they are compatible. But nothing is any more compatible with Angular.js. So when you look at different tutorials and so on, just check that it's actually using Angular 2 or later. They are ramping up the development, so they try to get new versions out a lot quicker than previously. So by now we're actually up to Angular 7. But the changes aren't that big for each of them. Also notice that there's no version 3. And I know why, but I won't tell you, because we need to move on. It is a complete framework, meaning that it has built-in functionality for most of the things that we would like to do. But there are also add-ons. And the reason why I say this is that one of the so-called competitors to this, the React library, is just that. It is a library. It has fewer functionality, and it's concentrated on bringing power to the developer, but the developer needs to create more by themselves. Again, this can be alleviated by using third-party libraries that are available for React as well, but when it comes to Angular, it is more complete. It also has great tooling support, and we'll talk more about that later on, but this makes it very easy for us to get up and running. Yeah, it's cross-platform, so if anyone still isn't using Linux, it's also working on Mac OS and Windows. Basically, as it is now part of the Node ecosystem, we need to install Node and npm, the Node Package Manager, which isn't that much of a problem today. And also, in order to get everything up and running, we need to install the Angular CLI, it's command line interpreter. It's not strictly needed, however, it makes life so much easier. So, if you don't install it, well, you're basically stupid. Okay? Great. There are it's a command line tool, but there are a bunch of GUI front ends to it, like for example the Angular console. But I usually prefer to, there's just a few commands that you need to run. So most often run it just from the terminal. Download latest version, LTS version of Node, and you also get the npm tool. These are the things that you need. If you go to angular.io, you get all of this information. It's not that difficult. What's not stated over there, but and it's not strictly a necessity, but if someone of you are still using Windows, the git bash tool for a git terminal or prompt is recommended. You can look at that over there. You don't have to use it, but it's good. Editor IDE, and almost everyone today are using Visual Studio Code from Microsoft in order to code for Angular. And even I, who might have one or two words to say about Microsoft, has to say that Visual Studio Code is really, really good. If you don't want that, I can also recommend JetBrains WebStorm, which you can get as a student for free. It's a really competent tool as well. This is Visual Studio Code, so it's a bit more old-fashioned, so to say, the text-based looking, like the good old days. There are themes. You can use a black theme, dark theme if you like. I don't like it, so therefore it's wrong. But they are available. Same goes for WebStorm. There are these really, really dark black on black on black themes, if you like. No one can see anything. Security. It doesn't matter what you use. Both of these are really competent tools in order to use it. Install the Angular CLI. It's just one npm command. You can see more CLI Angular IO. I bring this up because sometimes you get a number of warnings and error messages, but as long as ng-version works, you should be fine. Okay? Then the fun thing begins. Yeah, it begins, namely to create something. And we will use this Angular CLI tool, which is called ng, and all of these with a little $sign. I just expect you to be in the terminal and somewhere where you will be placing this project. And you just type ng new and then a project name. And if you don't put in a project name from CLI 7 and later, you will be asked for a name. Sometimes you will also be asked for routing or style sheet format, and you can just skip routing for now, and you can set style sheet format to CSS. The funny thing with this is it will begin to download a lot of files, and a straight-on simple Angular project with nothing added except the files that it needs is about 300 megabytes. So there's a lot of stuff, but it downloads everything that it needs, the complete environment. Okay? When we will trim it down, when we will create a build version of this, a production version of this, it will trim it down to just a fraction. You will get down to perhaps a few hundred kilobytes instead of these 300 megabytes. But this also means that I do totally understand if you don't want to have 15 Angular projects just everywhere, because they will eventually take up space. even if you sneeze at 300 megabytes. That's nothing. The latest movie I downloaded illegally was, yeah. This is a web application, so go somewhere, go in the terminal to where you installed it, created it, and you can do that as soon as you've done this ng new and project name and filled in the details. Go to that directory, stay there in that directory, and just type ng serve. And everything will be up and running. It will start a little web server, it will compile all the files, it will set everything up, and it will also point a web browser to it. If you use WebStorm, you can just click the play button if you see Angular CLI server. There is a terminal window in VS Code as well. I usually have a number of these terminals up and running on the screen when I do this. So I have one terminal window just for ng-serve, and then I have another window for creating components, as we'll see later on. Except from being a really great way of working, it also looks really cool, and that's important if someone sneaks in and look at you. Yeah, cool. So we open up everything, we run everything, and we go to this web page using a web browser of choice. You will see that I'm using Firefox Developer Edition because it gives me a few additional things to help me when it comes to development. Just go to localhost and port 4200, and if everything worked out, this will pop up. And Angular Lectures here is the name of the project. And we will look more deeply into what all of this is after the 15-minute break that begins now. And we're on again. We have a question.
For Git bash, do we need to mean TTY, or are we supposed to use the CMD?
The CMD, I think. Yeah. Git bash question. We will be available for answering a few questions. For this Windows stuff thingy, I'm not that very well into that, but we will help you as much as we possibly can. All right, we have a new project in Angular. We have it up and running using all the tools. Now let's dive into what this actually is. And if we look at the project structure, we can see that if we go to the project folder, we will see there are loads of files, and that's not very strange since it's 300 megabytes. And we have a number of folders, E2E, which is for testing. We won't touch that really. And then we have node modules, which are actually the bulk of the 300 megabytes, because that one contains all the different things that we need for Angular, all the different modules that it consists of. So if you want to say so, Angular itself is contained in there. And then we have a source folder where we put all our other stuff, and that stuff we'll see later on is called components and services and possibly modules and so on. As it is right now, we have something called an app, and it has a number of files, CSS, HTML, TS, TS, and a module file over there. We have an assets, which is empty, environment, which contains a number of files, and then a number of things that we will rarely look into. We have somewhere a main TS, which is an entry point for the application itself, but we will never really touch that one. We have an index HTML somewhere over there, which is again the entry point of the web part of this application, but we will rarely touch that one either. We will, but we will rarely do. And then styles for global styles, polyfill for making it work on different browsers, and so on. So that's where we are going to hang out for the rest of this lecture. Yeah. And what is a Angular application? Well, as it is a single page application, it consists of what we are calling components. And when it comes to this first thing that we met, it's the entire web page. Later on, we are going to introduce a number of other components. So we can have a component over there, we can have a component there, one there, and one there, meaning that we have the entire component, the app component, and inside of that component, we will have perhaps a header and a footer component, and we will have a number of content components for different things, and so on. And when we go to different pages in this application, what will happen is that we will switch out one component for another component. And this component can put perhaps things in this compartment, and so on. So we will create the application by creating a number of components doing their respective things, and a component could perhaps be entering data, searching product in your case. You could have a component for listing sold components and a number of other things. In order to help this, we have something called services, and I'll talk more about all of this later on, but services basically means things that a number of different components could want to use later on. So in this case, we have a database access there and something like that. Later on, we will see that all the things that we do with with Firebase will be based on services. We will have an authentication service, we will have a database, so to say, service, and perhaps storage service, and so on. So things that we can introduce into the different components, so that many components could benefit from using. Other than that, we have modules that tie together something cohesive. It's made for bootstrapping, routing, and also for just defining the entire application. Okay? So that works on the outside. It's actually quite a lot to begin with, but the more you work with it, you see that, well, we will sometimes work with modules by just adding stuff that we would like in our project, like Angular or Bootstrap or something like that. And routing is a module, so we will add that. And then we have services, and yes, we will create services for getting and manipulating data and so on. But we will mainly create components. And a component, therefore, is a defined part of the web page. So it's a small piece. Yeah, a question?
So each button in the web page, it could as a component individually?
If each button is a component.
Yeah.
Well, no, not necessarily, because you can have a component with many buttons in it doing different things. But every part that's actually doing something, like for example, as I said, you can have you can have a component that lists all the items in your web shop. That could be one. And you can have another one that is adding products to your well, to all your products, so to say, so to your backbone database. And then you can have different buttons in that component saying, well, add this, add this, add this. But hopefully you will see more in just a while of how it works. Each component consists of 3 different parts. HTML for defining the structure of it for the view, CSS for the style. So basically it is a mini web page. And it also has a third part, namely the TypeScript for the behavior, which makes it possible for us to create interactions, storing data, doing things depending on what the user is doing. But see it as a small part of the web page, and it's actually a small web page in itself, and we will just swap these out. Testing it's outside the scope of this course. We have this app component for now, and we will navigate between many different components later on. Modules, as I said, for bringing things together. We won't look a lot at that, but we will add to this root module, this app module TS, where we will put things like database access, for example, later on. It also bootstraps the entire application, gets it starting. And services, as I said again, everything that has a very narrow and well-defined purpose, making it possible for us to reuse this little part in many components, like authentication or database access. I mean, if we want to work with the database, okay, then both the list products component and the add products component will need this access and use this service. They are what's called injected into the components, so they are marked as injectable, and it's part of what's called dependency injection, that we can inject things into other things. And routing is mainly for navigating between these different parts. So when we set up routing, what we are actually doing is saying, well, when you go to this URL, this component will be shown. If you go to this URL, this component will be shown. And we can add authentication to that step, so to say, so that we know that for certain URLs you need to be authenticated in order for you to see it. And an even closer look reveals that we have an index HTML, which is normally the entry point of a web application, and it still is. But if we look into it, if we look at it, it doesn't contain very much. And what's even more interesting is that if we look at the body, it contains something like this, app root. What the heck is that? So app root is not, as far as I know at least, a HTML element or tag. So what this is actually the component called app. So to add to the understanding of how this works, each component will also create its own element or tag. So if you want to create a page with many different components, you compose them just as a normal HTML page with any kind of layouting, and then you position the different components with their respective tags where you want them. And the app component, as I said, has a number of files, CSS, HTML, and TS. It's also something for testing, but you will be testing your applications, but you don't have to use this way of doing it. But it contains everything that we need in order to display something on the web page. And we also have the app module TS for the entire project. So that's a module for the entire project, not just for this component. So not all components will have a module attached to them, but this first one will. And if we look into this component, we will see that it looks like this. It has something looking like this, an import of some kind. It has something that looks like a annotation, and it is. And then it says export class, and it has a variable called title. This is TypeScript, and we will look more into that in just a few seconds, or minutes probably. But what we can see here is that this file, this app.component.ts, contains everything that makes this component by saying that the selector, the element, the tag for it should be app root. If we change this, we need to change it in the other place as well. It uses a template, which is the HTML. So we point to an HTML file, which is the one that we have in our directory. And it has styles using this CSS. And then it has some sort of logic. And we can see that each and every component is a class. And we'll look at this a bit more closer in just a few minutes. We have a variable called title. And if we're at this position in our program, we can just change. You see that this Angular lecture, if we change that to Hobgoblin and hit save, and you're doing that, yeah, and we hit save, the machinery will kick on, and it will compile this into JavaScript, and it will put everything in a single file, and it will fire it up in our web browser. It will even, if we have this page open and we hit save, it will even tell the web browser to reload this page because it's new. and we will see that the title will be Hobgoblin instead. So it helps us a lot to do that. Bootstrapping is done in main.ts. If you're ever in this file, you're probably in the wrong place. So the module file, as I said, we will add a few things to that later on, but just a few things here and there. It's for adding more functionality to our application. And as I said, we are working with a complete environment, so as long as you have this ng-serve up and running, it will, as soon as you hit save in whatever IDE you're using, it will transpile all the files into something that it puts on its web server, and it tells the web browser that an update has been done. And we say transpiling because it's not really compiling, as it's not doing binary code, it's just making JavaScript of it. So working with this will be fairly quick. It's a nice environment to work with, and especially if you have many monitors, it's really nice to have your working area with your IDE over there, and then you have Firefox on the second screen, and then you can look at on the third screen you have your different terminals up and running, so you can see what's happening. And that was just me bragging about having 3 monitors. However, in order for us to do this, we need to understand TypeScript. So the next part will be TypeScript. And it will not be a complete guide to TypeScript, but it will be a beginning. Because the good thing with the TypeScript is that it's really quite easy to understand once you understand programming. I would say it's much more like Java than JavaScript is. It has a few quirks and it has a few additions that makes it really easy to work with. Well, once you get to know them, working with TypeScript is most often quite intuitive and quite fast. And when they created version 2 of Angular, they realized that JavaScript has too many problems for it to be a good fit for large projects. So the no type system and the poor object orientation, for example, makes it really unfit for really large projects. So they wanted something else, and they looked. They have their own programming language called Dart, which is beautiful. You should look it up. And there's even a version of Angular called Angular Dart. But nevertheless, they choose TypeScript. Even though they have their own programming language, which is beautiful, they choose TypeScript. And I'd say that that is most likely because TypeScript is a superset of JavaScript. So any JavaScript program is a valid TypeScript program, but not the other way around. So it adds functionality and adds ways of working. And we can argue that a programming language like Dart and Angular Dart are, in the long run, perhaps better, because Dart imposes a lot more good ways of programming, so to say. It's a better language as such, but it's more its own language. By using TypeScript, we get, I'd say, the best possible JavaScript. So we can benefit from knowing JavaScript, we can benefit from all the different scripts that are available out there on what's called the internet, because loads of stuff has been done using JavaScript. We can use that. It's not that difficult. Whereas if we choose another language like Dart or Elm or CoffeeScript or whatever, we couldn't do that. Okay. So it's a programming language on its own as well, so you can just use npm to install it, and you get a little TypeScript compiler and you can work your ways out. It's included in Angular, and you don't need to do anything with TypeScript outside of Angular. So we'll just look a little at what we have. Stronger typing, we have types. It's called TypeScript. Better object orientation. Well, yeah. Compile time errors because of this, making it easier to debug, easier to find all the errors, and it's got great tooling support in, for example, VS Code. Both VS Code and TypeScript are from Microsoft, so they work very well together. And as it is a superset of JavaScript, it really transpiles really, really fast, faster than other languages would have done. Okay, so we have a number of types. We don't have that many types, but we have a number of types. We have any for the lazy ones. Okay, I don't want to make a commitment. But we also have string, and we have number, and they've been a bit lax there. Okay, it's any number, but that's usually sufficient. We got a Boolean, enum, if we want to create lists of values. And there are a number of others like void, tuple, never, and object as well. And we'll see how we work with these. We've seen the var untyped JavaScript like this, as previously. And that has a number of problems. No typing, and also the var keyword makes it possible. Well, it defines the variable, and it's available everywhere. Basically, it's globally available. Whereas let will make it scoped, as we would expect from Java, for example. And we can define a type, colon number, so we put it the other way around, which is kind of cool. And we can assign a value as well. It is, however, inferred, so in this case, we don't have to put number over here. We don't have to define this as a number if we assign it to 3. Because if we assign a variable to 3, then it infers that this variable will be declared as a number. And if we assign it to 3, T-H-R-E-E, yeah, so the letters, then we have a string, and we don't have to say that it is a string if we assign it a string, because it knows that. And it will not change it. We will still get errors later on. We should say that this let is also available, of course, in newer versions of JavaScript, but you cannot rely on it being there. And functions, the same there. We can say that we want x and y to be of type numbers, and also that we will return a number. And as it has to be backwards compatible with JavaScript, or rather JavaScript should be possible, we still have the keyword function over here. So therefore they needed to put the return type over there. They can be anonymous, just like in JavaScript, but with, as you can see over here, types. So square in this case is a function which takes a number and returns a number, and the implementation is x plus times x. And we can do this with a arrow function instead. So we can say that new square should be something that takes a number, returns a number, and the implementation is x times x. And you can even omit the curly brackets if we are not returning anything specific. And we can make classes, real classes. Yay! Class point x, y, declared as numbers. We have a method draw, get distance, some implementation, whatever it might be. And we create, as you see over here, objects like we do in Java. But it does have a number of additions. And first off, it needs to work with some of the problems that are available also in JavaScript. And one of the problems that we have is that in TypeScript and in JavaScript, we can only have one constructor. Yay, one constructor. Use it wisely. However, if we want, we can add these question marks after the variable name, but before the type. And it will be optional, meaning that we can call the constructor creating a new object and supplying none of the in parameters, one of the in parameters, or two of the in parameters. If we just apply one, it will be the first one. Access modifiers, we can of course say that we would like it to be private, so we get some encapsulation, one of the cores of object orientation. And we can even initiate and declare and do a lot of stuff directly in the constructor, meaning that if we create a constructor like this, constructor, and then we say private X is optional of type number and private Y is optional of type number, we don't have to put this inside of our class because it's right there. And we'll see later on that when we create services and we use services, we will do just like this. And it's also something that we usually see when we work with Firebase. Properties for getters and setters. So we can do something like this for the Y value, but it's also possible to use get and set with a capital version of the variable, the field variable that we're using. And if we do, we can use it like this. So point dot capital X equals to 12, or should be assigned 12, or something like this. So that means that we can set and get without the parentheses. And therefore, a lot of people, if they perhaps they want it to be not the capital because it looks ugly, they use underscore, and you'll see that from time to time on the internet as well. Because then you can have a get and a lowercase x. And modules, each file is a module. If we want to put it in a separate file, in a module, we can also structure the application a bit better. And then if we want to use this file somewhere else in another file, we need to export the class. And that's just how it is. Classes which don't have export are only working in that file or module. But if we want to use it outside, use export. And that means that we can import it. And importing is done, as we saw just briefly when it came to components, by import, curly brackets, name of the class that we want to import from, and then a relative path to the file with no extension. So we don't say .ts. And again, using either Visual Studio Code or using WebStorm will help you a lot in doing this. When it comes to the built-in functionality, you can start using something and it will just import it for you. It has decorators, metadata, as you've seen in Java as well. Mainly a way of saying that this this, whatever it is, in this case classes, should have a specific kind of functionality. We've seen it with component where we set the selected templates and styles to something. You can create new decorators, but we won't do that because that's not what we're up to. We are just going to use them, but then you know that this is, just as in Java, a decorator. Adds behavior and intent for the class, and this makes it easier for the transpiler to actually transpile it to JavaScript. There's lots more you can learn about TypeScript. And I don't have a lot of links, I remember right now, but go to TypeScript's webpage, typescriptlang.org, and you'll get loads of information. So, instead, we are going to dive into components. By now, I assume that you know what Angular is, how TypeScript works. Now let's see what components are. Yeah, I know. It's fairly fast-paced, but once you sit down and you look at the different things and you try to just doing this short change of the variable title to something else makes for a lot of understanding basically for this. So components are a part of the web page, will help to show and collect information. They are the main part of an Angular, I said component over here, but application. It's a class and a template, which is a view, and each application has several of these components, so you can reuse them. I mean, a good idea is to create components for user creation, user login, and so on, and you can copy and paste these or reuse, I should say, these in later projects. We are just going to make one project in this course, but you could potentially use them for many. The structure, as we've seen previously, import something. Now we know it's actually importing something, and in this case it's importing component from Angular core, which we will find in the node modules, and they have this @ sign in front of them, and then the decorator telling us which files we are going to use and what our name is, app component and the title, and then in index.html something like this. Now the default component is this one. Okay, so the other teacher just mailed me and said that the groups look fine. So I will publish the groups after this lecture. Okay, the view is a HTML file, and it also has quite a lot of files. But what we are going to do now is to delete everything in the HTML file and add a image file instead. And I've downloaded a nice PNG, and I put it in assets, and I just add this. However, that didn't look very good, so I want to add some CSS code, so I put this code into the app.component.css. We don't have to deal with where to include stuff. We just add this to the CSS file, and then we can call the class logo as we have over here. And if we do that, add this to the CSS, remove everything from the index.html, we add this, and we get something like this. And I mean, it's not complete, but it's not bad. But we want more components. As I said, an application consists of a number of components. So we do that via the tool ng. So again, we go to where we or rather should have always a terminal up with your project directory. And if we go there and we use ng, we have the generate parameter, which tells us that we want to generate something. We can say that we want to generate a component. Later on we will also create service, and we will create module, and then where we want it. And components, I decide that I would like to put things in a folder called components and a slash, and then I call it Jedi. Okay. If you're lazy, this generate component, it's very difficult to type. I get so tired in my poor little hands. Then you can just say ng gc and then components slash Jedi. That works as well. Now, under source app, we will have a new folder called components, and it will create a component called Jedi. And it's basically empty. But it creates all the different files, so a TS file for the behavior, a CSS file, and an HTML file. All of those plus a testing file it creates for us. If we go in, we add a few things. We add these things to the CSS, and we add this to the HTML file, and nothing else. Nothing else. Just those things in those places. If we look into the appjedi.component.ts, which is the name of the component, we see that the selector is app-jedi, which is the normal way of doing it. So something like that. So then we go back to our app component HTML, where we had this logo, and we just add this new element that we have, this new tag, app-jedi. Notice that we need, for some reason, and I actually don't know why, but we need to have a starting and an end tag for this. It's not enough to say app-jedi/. We need a starting and an end tag. But if we do this, we get something like this. So what did we do actually? Yeah, we have a new typeface, and we say that for P we want to use this one and a title. Yeah. So the Star Wars archive, welcome to Star Wars, blah blah blah, and so on. This is one component. This is another component. And I usually create my applications like that. Things that I always want to have on my web page, I put in the app component. And the things that I want to change from time to time, I put in the HTML of the app component. So if I, in the app component, create a layout, because I have no layout over here at all, but if I create a layout where I want to have something like a menu system over there, a content area over there, I can do that in, for example, the app component. Okay, so it's starting to get there. But we also want to create some sort of behavior. We want something to happen. We do that in the TS file. And in the TS file, we have a number of when we look at it, we have all the component annotation, and then we have a constructor, and then something called an ng-on in it. We didn't see an ng-on in it in the app component, but in all other components that we generate, we will have a ng-on in it. And we can also add a constructor. We can define a variable like this, just as we usually do in a class. Name Cesartine, like this. The lint tool, the tool that makes us create beautiful code in both VS Code and in WebStorm, will tell us that we will use single quotation marks for for strings, and it will give us a little lint error if we don't. However, it will actually work even though even if we use double quotation marks, but it will tell us that it looks ugly. And again, we don't need to say that this is a string. Name will be declared as a string as it's assigned a string. And then we have this console.log, which makes it possible for us to print something to the log, which we can get from the if we look over here. If we go to the developer tools, if we go to it's somewhere similar in all web browsers, but over here, the menu, get to developer tools, and we will get an expector, console, debugger, and style editor, and so on. The console, well, if we look there, it will say hello from C13, because we said hello from plus this variable, and it will print that out. It's not much fun because we can't have the users look in the console, but it's a good place to put things that we want to check. So just check. This is TypeScript, so we can create methods, say name. In this case, it will not return anything. It would just put something in the log. Notice that when we want to use name, the variable, we need to prefix it with this. And that's just how it is. To get the variables that are available globally, so to say, in this class, we need this to precede it. And then in the constructor, we can say this say name, and we will get the same result as previously. It will print out hello from C13 in the console. But what it is doing is showing that we can create our own methods that we can use. And lastly, because this is more fun, one of the things that Angular is doing very well, and a way for us to actually get something to the web page, is string interpolation. It's a powerful tool which in a way for us is one part at least of the connection between the logic that we create in the TypeScript file and the view in HTML. And we are using the double curly braces notation in order to say that we want to print something out here or make a calculation. If we just do it like this, and we do this in the HTML file. If we just put this in our HTML file, it will just print out hello world. However, we can also make it use the different things that we have in our TS file. So, if we have, for example, the important thing is that we have a variable called name. This is wrong. I don't know why. Okay, so we have name assigned C13, as we saw previously, and we also have a method called show home world, which returns a string. And then in HTML, if we use curly brackets, two of them, name, we will get the information from the variable name, the contents of variable name, and then we, from, and curly brackets again, show home world, we will call the method called show home world. So if we have all of that, we actually get this over here. So C13 from Ikuch, like this. You can't see it really, but the idea here is that we bind the information that we have in our TS file to the web page using these curly brackets. And there's loads of more that I would like to talk to you about this, but we'll end for now because yeah, I won't say it. So, thank you everyone. See you on Friday. Pigga och glada. Hej!